Okay, and Z size L. Apply, click OK. So radiation box will be created. Okay, one radiation box, that is 8. Now we will check the previous design one. So that inside the radiation box, inside the rectangular waveguide, we will take material as a vacuum. So go to our project and air 1. We have to assign air 1 with, okay, please remember 1 is filled with. How our design was completed. We have the vacuum inside the rectangular waveguide, and inside the radiation box we have the air, and this entire material is copper. Okay. Now validate your experiment. HFSS validation check. So analysis setup was pending. Okay. Now just click analysis, add solution, advanced, and take solution frequency 10 GHz. Passes you can say, click OK. And next you can take 5 to 15 GHz frequency range. Frequency is 5 to 15 GHz. Okay. Now analysis setup will be completed. Just to go to HFSS validation check, everything will be completed. Okay. Now you have to analyze this experiment. Okay, you can give the different name. I am giving rectangular 1. Okay, and save this one. It will take some time to analyze the experiment. Okay. So we are designing this type of structure. I think you know the cutoff frequency of the rectangular waveguide will be Fc is equal to 1 by 2 pi root nu epsilon square root of m pi by a whole square plus n pi by b whole square. Okay. So we have different modes in rectangular waveguide. Now here I just explaining TE10 mode. So A value will be 1. So TE10. So M we're taking 1 and n equal to 0. Automatically this term will be 0. M value 1 by A, pi by A whole square. Just substitute M value 1 and n value 0. You can get the 6.56 GHz. So TE10, the cutoff frequency is 6.56 GHz. After that, the rectangular waveguide can allow the signals. Like that, you can study the different modes of the rectangular waveguide. Okay. So here, simulation is done almost. Okay. Now, perfectly simulation was done. Now go to results, create model solution report, rectangular plot, and go to output variables. Go to output variables. Okay. Now in place of name, type K naught, and the formula for the K naught is 2 into 3.14 into frequency divided by 3E8, and add this equation. Okay, and click done. And next, take mode 1, imaginary, type gamma of 1:1 divided by K naught, and add this equation. Similarly, mode 2 and mode 3. Okay, add this 4 equations. After adding, just click done. Okay. Now go to results, create model solution data report, rectangular plot, S parameter S11 dB. You can check or go to output variables, select mode 1. Okay, imaginary or real term. You can take any one. Okay. So here you can see output variables T10, that is starting from 6.55 gigahertz. So after 6.55 gigahertz, the wave does not attenuate it. Similarly, I selected mode 1, mode 2, mode 3. Okay, you can observe the 3 modes of the rectangular waveguide. Okay, and you can see the impedance versus frequency graph also. So at mode 1, 6.5 gigahertz, we are getting this much of impedance. Okay, so how you get these graphs? Just click create model solution data report, rectangular plot. Okay, output variables, mode 1, and just click new report. You can see mode 1. Just mark, add marker. You can write, you can see 6.5 gigahertz S11 value. And similarly, you can apply note also. Add note, mode 1, click OK. And drag this one here. If you want to get mode 2, mode 3, just results, create model solution report, rectangular plot, output variables, mode 1, mode 2, mode 3, select all these things by selecting control button and click new report. So you can get 3 modes. Okay. First mode, second mode, third mode. Okay, these are the frequencies. Okay, like that you can see the modes. So how you set the modes? Before getting these graphs, just click on excitations port 1. Double click on the port 1. Initially you have number of modes 1. Just type 3 for port 1 and click OK. And similarly for port 2 also, initially we have only number of modes 1. Just type number 3. Modes will be allotted. After that, simulate the experiment. Okay, and then find the results. Okay, this is the procedure to find the modes in a rectangular waveguide. Thank you.